So we've studied parallelograms a little bit, and we've proven a few properties of parallelograms, looked at some theorems that said, okay, if this is a parallelogram, then this is true. Like the opposite sides are congruent, the opposite angles are congruent, that sort of thing. Now we're going to go the other way and say, okay, here's a quadrilateral. Can you prove that it's a parallelogram? So we're going to look at the converse of the theorems that we looked at before. So let's just go through these, and these are the main ones we're going to focus on: 6, 6, 6, 7, 6, 8, 6, 9. So let's look at this first one. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so we're looking at going the other way with this. So now, remember what a parallelogram is. A parallelogram is a quadrilateral and the opposite sides are parallel. So we want to keep that in mind. Okay, so if you want to show a quadrilateral is a parallelogram, you've got to show the opposite sides are congruent. So with a parallelogram, with a quadrilateral, if you want to determine if it's a parallelogram, you can do this. You can say, okay, are opposite sides congruent? If they are, parallelogram. Okay, maybe you don't know the side lengths, but you know the opposite angles. If the opposite angles are congruent, then it's a parallelogram. So we got these two. Now, here's the next one. If the consecutive angles are supplementary, in other words, if angle A and B are supplementary, if angle D are supplementary, if that happens, then your quadrilateral is a parallelogram. And finally, if the diagonals bisect, if the diagonals bisect, I should say bisect, if the diagonals bisect each other, then it's a quadrilateral. In other words, if they hit the midpoint of each segment, okay? So AC and DB, they both intersect right at the midpoint of each other. Okay, now, let's see how we would use that to prove that this ABCD right here is a parallelogram. Now remember, to prove that we have a parallelogram, what we have to do is we have to show this side is parallel to this side. This side is parallel to this side. This is what we have to do. So they're going to give us some information. We're going to use that information to get to that. Now, with these parallelograms, I mean, if we're trying to show that this is a parallelogram, in other words, if I want to show that this side right here is parallel to this side right here, what I'm thinking about is I need to show that this angle is congruent to that angle. So there I have alternate interior angles being congruent to each other. Now that happens when you have two lines cut by a transversal. Okay, so here we have these two sides of the quadrilateral, and the diagonal goes up through there, but we're going to look at it as parallel lines cut by a transversal. Now, if those alternate interior angles are the same, then those lines are parallel. So let's go ahead and start here. We have a statement, and we have a reason over here. Okay, now first of all, we're given that AB is congruent to CD. This is just given, so we get this out of the way first. AD is congruent to CB. CB. And that is just given. Now, I want to show that shape up there is a parallelogram. So here's my thinking. To show that it's a parallelogram, this side and this side. So to show that these two lines are parallel, I need to show that these angles are congruent. And the way I'll do that is to show that these two triangles are congruent. I'll show those two triangles are congruent, and then I can show corresponding angles are congruent. So that's how we want to proceed with this proof. And once we get that in mind, we can, we'll have a path forward. Now remember the ways that we have to find that two triangles are congruent. We have side, side, side. We have angle, side, angle. Side, angle, side. We have angle, angle, side. And we have hypotenuse, leg. These are the methods that we've used. Now, if you look at these two triangles up here, it seems like the path forward would be side, 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 because look what I can do. I can say AC is congruent to AC, okay, by the reflexive property. Okay? Well, heck, now that we have that, we have congruence. In other words, we have these two triangles are congruent to each other, this one and this one. So we just need to write it out and say the reason. The reason is SSS. So here's what we have. We have triangle ABC is congruent to triangle CDA. Okay? And that's by SSS. Yeah. Now, if that's true, then here's something else we know. We know that this angle is congruent to this angle. And we know that this angle is congruent to this angle. So I just need to state that. Here's what we've got now. We've got angle BAC. BAC is congruent to DCA. Okay. And then we've got angle DAC is congruent to BCA. Yeah. And that's because alternate interior angle, well, that's because corresponding parts of, I got ahead of myself, corresponding parts of congruent triangles, let me just abbreviate, are congruent. There we go. Writing takes so long. Now, as a result of that, we know that AB is congruent to CD. AB congruent to CD. And we also know that AD is congruent to CB. I mean, not congruent, parallel, I'm sorry. Yeah. And we know that by the definition of parallelogram. Actually, we know that by the alternate interior angles. Alternate interior angles converse is the converse. Okay. So if we show that those are parallel, then we know that the angles, the alternate interior angles are congruent. And now we have ABCD as a parallelogram by definition. So ABCD is a parallelogram by definition. Yeah, there we go. Okay, now, so there's an example of a proof, and I try to think that it's the thought process that you want to be in, that you want to get down. Remembering the names of the theorem and that sort of thing, the names of all the theorems, that's not the important. The important thing is that you understand how this proof thing works. In other words, and you get to where you can think through it and think logically through these proofs. Okay, now we've got also Theorem 610. That's just another theorem that was a part of the section. Let me go on down here to the assignment. And Mainly, this assignment is just computational, okay? And where we're going to use what we know about parallelograms to find missing parts, missing angles, and that sort of thing.